Now let's take a look at an example involving tables. So given the table shown for f at x, I'd like to create tables for a and b. So my original table is x with 0, 1, 2, 3, and 4, and f at x with 4, 6, 2, 0, and -3. So the first table I'd like to make is g at x, and I'd like g at x to be the negative of f at x. Now remember, as we discussed, negative outside is going to affect the y's. And so what this is going to do is this is going to negate the y's. The function g at x is actually the reflection of f at x over the x-axis. Since it affects the y's and it's the reflection over the x-axis, each point, AB, is going to become the point A, negative B. So you'll notice as we look at this that our points will be 0, -4, 1, -6, 2, -2, 3, 0, and 4, 3. Notice all the x's stayed the same. The y's just changed sign, of course with the exception of 0, which is a neutral value. Now, let's take a look at if we had g at x equals f at -x. Well, g at x equals f at -x, remember this is the reflection over the y-axis. This is when we keep the y values, but we change the x values. And so each point AB is going to become the point -AB. So you'll notice if I went back and looked at the original table had the y's as 4, 6, 2, 0, and -3, and now notice these y's are still 4, 6, 2, 0, and -3. The original table had the x's as 0, 1, 2, 3, 4, and remember we said we reflect over the y-axis, so we change the sign on the x's, and so we get 0, -1, -2, -3, and -4. So let's put this all together and look at one grand part, and we'll call this one now part C. We have this one g at x, and g at x is going to be negative f at x plus 3 plus 1. Notice this particular one involves two shifts and a reflection. The real issue here, and the part that gives students the most trouble, is determining the right order. We actually do the transformations in the order that is consistent with the order of operations. So we think of the negative as being multiplying by -1. We're going to think of the x plus 3 in the parentheses as something inside parentheses, and the plus 1 as addition. So thinking about it that way, remember we do what's in the parentheses first, then we would do multiplication or division, but in this case multiplication, and then addition or subtraction. So what we're going to do is we're going to do the horizontal shift first, the reflection, any reflection we have over the x or y axis, and then we're going to do vertical shifts. So what we have first is our horizontal shift, and remember x plus 3 in the parentheses means a left shift, so that's going to take all the x's and subtract 3 from them in order to move them to the left, but it keeps the y's the same. So the left shift takes our AB point and takes it to a minus 3, but keeping b. Now, the next shift we have, remember, or the next transformation, is the negative outside, and remember that reflects over the x-axis, so that changes the sign on the y's. So now our a minus 3, comma b, actually becomes a minus 3, negative b. And then lastly, we shift up 1 unit, and remember that took whatever y we had, and it adds 1, keeping the x's the same. And so our previous step, we had a minus 3, comma, negative b. Now we have a minus 3, comma, negative b plus 1. So now if I just went back to my previous table, or the original table, and I just did that, if I took each of the original values and subtract 3 from the x value, and then do negative the y value plus 1, that would produce the new table. You probably want to sit down and kind of go through that particular example and really convince yourself of how that works. It's really tricky, but it's actually one of the kind of slicker parts of the whole section.